Welcome back to a really important concept, the idea of assignment statements. These lie at the heart of programming. Some of you may think you know all about assignment statements, but please do bear with me. I think there will probably be some new things in here. So you've seen us type expressions into the Python shell. 2 plus 3 is an expression. We say Python evaluates it and prints the result 5. But you can also type in statements. Here's a statement. My age is assigned the value, which I type as equal 200, integer divide 2 minus 1. Nothing got printed. This is a statement and it gets executed by the Python shell. To repeat, expressions get evaluated, statements get executed. What do I mean by a statement? Well, a little bit hard to give you a good definition at this point, but the general idea is that a statement is the unit of a Python program, similar to the way in which a sentence is a unit of an English essay. A Python program is a sequence of statements. So this particular statement changes the state of the Python engine. It now knows something it didn't before. It knows about a variable, as we'll call it, called my age, which has an associated value, and that's what the assignment statement does. So it has 3 parts. There's a left-hand side, an equal sign, and a right-hand side. The left-hand side is the name of the variable that is going to be given a value. Remember, I stated that as my age is assigned the value that. The identifier, the name of the variable, on the left-hand side has to follow the syntax rules given here. It has to be made up of letters and digits. We call that alphanumeric. It's alphabetic plus numeric, or underscore. And it has to begin with either an alphabetic or an underscore. So here's a perfectly valid name for a variable. It's a rather long one, but it's perfectly legitimate. I can set it equal to 1. I can't, however, start with a variable name. I can't start a variable name with a digit. Like 1a is illegal. It gives me a syntax error. And there's a style rule I want to mention now, that at least until we give you certain exceptions, your identifiers cannot contain uppercase letters, only lowercase. Now Python will accept them, but they won't work in the quiz server when you enter them in, because there's a program we use called Pylint which checks your code and it will object to this sort of thing. So from a stylistic point of view, lowercase alphabetic characters only, please, in your identifiers. I said that when you enter a Python statement, it gets executed. Let's look at what that means. So we're going to execute the statement, my age is that expression. So the left-hand side is an identifier, the right-hand side of the equal sign is an expression. So the first thing that happens is the expression gets evaluated. Now to illustrate this, I've got a box here which I've labeled the object store. It's also going to be called the heap on occasion. So the object store has the current state of the Python program, which is a set of objects which have values, of course. I've shown a couple of stray ones here that I don't need, just to point out that at any time there's probably some other objects around, and there's one important object here called the current dictionary, also known as a frame, and it's an object too. It's a dictionary which lets you look up, or lets the Python engine look up, the value of any variable. Let's see this in action. So the first thing that happens, the expression on the right-hand side gets evaluated. That yields a new object. Notice these terms I'm using from the previous videos. There it is. There's the new object. It's an integer object with the value 99. The next thing the Python engine does is look in the current dictionary for the for the variable name on the left-hand side, my age. It doesn't find it. I'm showing this dictionary meaning empty. So it inserts it somewhere. There it is, my age. And then lastly, it sets that dictionary entry to reference or to point to the value on the right-hand side that it just evaluated. What do I mean by a reference? Well, let's not get too lost in detail. You may be just happy with that arrow, but I want to explain what that arrow really means. Computers have a lot of memory. An 8 gigabyte computer has 8 by 10 to the 9th bytes. 8 gigabytes. Each byte is an 8-bit unit of memory. We don't need to worry about the details. It's just a binary number with 8 noughts or ones. And they're numbered. This is a key idea. The bytes in the memory are numbered from 0, 1, 2, 3, all the way up to the size of your memory, in this case 8 by 10 to the 9th minus 1. And this number of a memory location is called its address. You can think of these memories as being like letterboxes on a street. They have an address, and inside is an object. So to find the value of a variable at a particular address, you look in the letterbox at that address, and there's the object you want. So that is what a reference is in this diagram here. That arrow denotes the fact that the myAge name in the dictionary has associated with it the address of the object. That is shown by that arrow here. Right, let's work through a sequence of 3 assignment statements which shows how variables actually get used. So the first statement we're going to execute is that one. It says myAge is 99. Here's our object store. We evaluate the right-hand side expression, which is very simple. It's just 99. We check, I say we, the Python engine checks in the dictionary to see whether there's a myAge. There isn't, so it adds it. It then links that to the object that was created. In other words, it generates a reference to it. Repeat with the next statement. Here we see the idea of using a variable name in an expression. Expressions can contain operators and operands. The operands can be numbers or strings or other things that we'll come to later in the course, but they can have a value, or they can be the name of an object that has a value. So if this is a name, it looks in the dictionary to find out what the actual object is and then gets the value. So myAge is a reference to this thing. 99 minus 1 evaluates to 98. A new object gets created. There it is. Left-hand side now. We look in the dictionary. Is there a value? Is there a string, his age? No, there isn't, so it gets added. And then a link or a reference is made to that object. Now we come to the most nightmarish looking of the assignment statements. If you're used to algebra, this looks like total nonsense, and indeed, algebraically, it is total nonsense. But this isn't algebra. This is programming. So this should be read, myAge is assigned the value myAge plus 1. We follow the same rules as before. We go to the dictionary to find myAge. There it is. It references this object, so we use 99. We add 1, we get 100. A new object is created. There it is, 100. We then look in the dictionary to find if myAge is already there. Oh, it is. It has to be reset to point to the new object like that. So that's what this sort of weird-looking algebraic nonsense means in programming. It means set the value of the variable myAge to the result of evaluating this expression here using the previous value of myAge. And that's what happened. One other little aside here, I want to mention that lowercase alphabetics are different from uppercase. So a variable called capital M myAge is different from lowercase m myAge. One last thing in this video, combined operators. We often set variables up to, for example, count something. We initialize maybe the count to 0, and then as some event happens, we go count equals count plus 1 to add 1 to it. So now if I look at the value of count, it's 1. If I do it again, then of course it's 2. Let's check. There it is, 2. This is very, very common. That's called incrementing a variable. We also decrement them, and we sometimes multiply them by 2. So I can do count equals count times 2. You hopefully can figure out that now it should be 4. These are so common, we have a shortcut notation. We write this statement here as count plus equal 1. And we write this statement here as count times equal 2. That's all there is to it. It looks confusing. You just have to get used to reading that as that in your head. And this is just one of those things that takes practice. And lastly, in the example here, I've got this hash here. The hash is a special character. If it occurs in a Python statement, it means that the rest of the line or statement gets ignored. It's just comment. And that's it for this very important video. You may want to watch it again because it's absolutely critical to understanding the rest of this course. Thanks for watching. Bye.